Hello guys, let us continue with the types of matrices from our last lecture. We had seen in the previous lecture the row matrix, column matrix, square matrix and the rectangular matrix. These were the four types of matrices we covered in our last lecture. Now the next type of matrix that we have is a diagonal matrix. So for us, a simple point to remember that diagonal matrix, it is also a square matrix and the element in position Aij, where I is equal to j, are non-zero and other elements are zeros. Let us understand this with an example, guys. If you remember from our last lecture, we had seen the position elements where we say, suppose if I consider this as my matrix, this is your position A11, this is your position A22, this over here is the position A12, this position is A21. So if you observe something, when I and j are equal, it means that 1 and 1. Again I and j are equal, A2, 2. In these positions, we are having non-zero numbers, whereas in the remaining positions where I and j are not equal, A12, A21, then in such a positions, because we are having 0, therefore this kind of a matrix can be called as a diagonal matrix. Let us take one more example, guys. Let us take one more example over here. I have written the numbers. If you observe carefully, this is your position A11. This is the position A22, and this is the position third row, third column. So A33. So these three elements are non-zeros, whereas all the remaining elements they are zeros. So this kind of a presentation of numbers is called as a diagonal matrix. These elements 3, 2 and 7 are called diagonal elements. So that is a very important type, guys. Based on this, there are two or three more types based on the diagonal matrix. So let us see what is the next. Number 5, called as scalar matrix. So over here, it is a diagonal matrix with all diagonal elements diagonal elements equal to each other, and as usual the non-diagonal elements are zeros, as in case of the diagonal matrix. So once again, let us take some example. Suppose if I take -7, 0, 0 and -7. So over here, these are the diagonal positions, diagonal elements. So the diagonal elements are non-zero numbers, whereas the other elements are zeros. According to the condition of the scalar matrix, all the diagonal elements are equal. Diagonal elements are equal. Therefore, this kind of presentation of the matrix called as a scalar matrix. Let me take one more example, guys, quickly. 2, 0, 0, 0, 2, 0, 0, 0, 2. You can see over here all the diagonal elements are equal to 2 and the non-diagonal elements are 0. Therefore, again, this kind of a matrix is called as a scalar matrix. Is that very easy, guys? Next number that you are having over there is number 6. Identity or unit matrix. Again, it is a scalar matrix with all diagonal values equal to 1 and obviously remaining elements equal to 0. So I get over here 1, 0, 0, 1. Otherwise, if it is a 3 row 3 column question, then you will take 1, 0, 0, 0, 1, 0, 0, 0, 1. In general, identity matrix is represented by I. So we say that I is equal to 1, 0, 0, 1, or again in case of a 3 by 3 matrix, it will called as I. In case sometimes your question tells you I2, I3, but still that does not make a big difference. I represents identity matrix. I2 represents identity matrix of 2 by 2 order. I3 represents identity matrix of 3 by 3 order. Okay. I hope that this is a very clear point. It's a very basic thing, guys. After this, the next type of matrix that we have is symmetric matrix. It is very important matrix. Once again, let us understand symmetric matrix. Once again, symmetric matrix has to be a square matrix. Has to be a square matrix. And the condition is that Aij element must be exactly equal to Aji element. This is the required condition in case of a symmetric matrix. If A12 is equal to 7, this implies A21 should also be 7. If A13 is equal to 9, then A31 should also be equal to 9. If A23 is equal to 8, then it implies that A32 must also be equal to 8. In case if it is negative, then this will also be negative. So if I write this in the matrix format, I get it like this. Suppose if I take 3, 5 and 0 over here, there is no condition on the diagonal elements. Diagonal elements can be anything. If I take A12 as 7, then you can see over here A21 is also 7. If A13 is equal to 9, that is this position if it is 9, then A31 must also be equal to 9. If A23 is negative 8, then A32 should also be equal to negative 8. A very simple example over here, guys. One more example. As I told you, no condition on the diagonal values. So 7 and 11 are just as it is. If I have minus 2 in this position, that is A12, then A21 position element will also be the same minus 2. Now that was the symmetric matrix. Similar to this, we have skew symmetric matrix. So now let us understand what is a skew symmetric matrix. Again, it has to be a square matrix, and now let us see what is the condition. There are two conditions for this. The first condition is that Aij is equal to minus of Aji. Second condition is that diagonal values are compulsory equal to 0. So these are the two conditions that we have to remember when we are talking about the skew symmetric matrix. Diagonal values must be compulsory equal to 0 and Aij is minus of Aj. Let us once again see an example, guys. If I have A12 as 3, this implies that A21 will also be equal to 3 but with a negative sign. If I have A23 is equal to minus 6, this implies that A32 will also be equal to negative 6 with a negative, so negative and negative will become positive 6. And if I have A13 as 11, then in such a case A31 will be negative 11. So if I write this in the matrix format, as I told you that diagonal elements have to be 0. So these three elements are zeros. Now if this over here is 3, then A21 is negative 3. If A13 is equal to 11, then in that case A31 will be equal to negative 11. Finally, if this is minus 6, I get this number as 6. Very simple, guys. You need one more example. Let us take another example, guys. A 3 by 3 only. These all are zeros. If this is 5, A12, A21 will be negative 5. If A13 is 7, then A31 will be negative 7. And if A23 is equal to minus 6, then this is going to be positive 6. Very simple. Okay guys, so that's about your skew symmetric matrix. Now after that, let us talk about the next type of matrix, which is upper triangular matrix. Upper triangular matrix. So the condition for the upper triangular matrix is that condition the elements above diagonal should not be equal to 0 and elements below diagonal have to be equal to 0. So for example, these are the diagonal elements. There is no condition on diagonal elements. They can be 0, they can be non-zero, but compulsory above the diagonal there has to be any non-zero number, positive or negative. Below the diagonal, compulsory it has to be 0. Second example, if I take this as 7, 6 and 0, above the diagonals it has to be non-zero. Let us take minus 5, 2 and 3. But below the diagonal they have to be 0 values. So in such a case it will be called as an upper triangular matrix. After this, a similar matrix that we have got over here, it is called as the lower triangular matrix. Once again, the condition for this condition is that elements above diagonal are equal to 0 and now the elements below diagonal should be non-zero. Diagonal can be 0 or non-zero, it is not important. For example, elements above the diagonal are required to be 0. So diagonal, if I take 7 and 11, let us take a 0 above the diagonal. But below the diagonal it is non-zero, positive, negative, not a problem. So let us take minus 5 for example. One more example of a 3 by 3 matrix we can take 6, 0, 2. All the elements above the diagonal are 0. Below the diagonal compulsory non-zero numbers. So that was about your lower triangular matrix. Then the next thing that we have to learn under this is about the singular and non-singular matrix. Singular and non-singular matrix. Okay, so when we talk about singular matrix, condition for singular matrix, determinant of that matrix must be equal to 0 for non-singular matrix. The determinant of the matrix must be non-zero. So that is the condition for singular and non-singular matrix. Determinant is a chapter that you have already studied in your 11th standard, guys. Finally, the last thing that we will be covering over here is about the transpose of a matrix. Now, what is the meaning of transpose of a matrix? It is just interchange of rows and columns. For example, if I have a matrix A which is 3, 2, 7, 6, then in such a case we can say A dash or AT, which represents A transpose. The first row will become the first column, so 3, 2 will come out to be vertically, and 7, 6, that is the second row, will become my second column. So that is about your transpose. Let me take one more example for you. Matrix B. If I have 1, 5, 9, 2, minus 4, 6, then in that case B dash or B transpose is given by 1, 5, 9. The first row will now become the first column, and 2, minus 4, 6. The second row will now become our second column. Thank you, guys.